Hey everyone, welcome. So, let's talk about logic. For most of us, it's all about finding the right answer, right? Well, today we're going to flip that completely on its head. We're going to explore this really cool idea that suggests the true power of logic. It's not in the answer at all, it's in the question itself. I mean, think about it. We're always taught that logic is the science of certainty, proving things, getting to the one correct conclusion. But what if that's just half the picture? What if the real logical structure, the heavy lifting, isn't about getting to the final destination, but it's actually in the map of possibilities that a question creates for us in the first place? Okay, so to really dig into that idea, we're going to need a whole new toolkit. And that brings us to our first section. What is inquisitive logic? It's all about a new way to look at meaning. So the core idea here is something called inquisitive semantics. And really, it's all about this big idea of a unified framework. You see, traditional logic has always kept statements and questions in totally separate boxes. You have, it is raining, which is a statement, and is it raining, which is a question. Two different beasts. But inquisitive semantics comes along and says, hang on, what if we build a system where they can exist together, where one single sentence can both provide information and raise an issue at the same time? Let's break that down. It's actually pretty simple when you think about it. An assertion, that gives you information, right? It narrows things down. If I tell you the keys are on the table, suddenly all the other places they could be, they're gone. We have one possibility. But a question does the complete opposite. If I ask, are the keys on the table or are they in the drawer? I haven't narrowed anything. I've actually just raised an issue by putting two distinct alternatives out there for us to think about. All right, I know this phrase, a set of sets of possible worlds. That sounds super abstract and maybe a little intimidating, but just stick with me because the idea behind it is actually really cool. Just go back to that map analogy. A simple statement, like, we are here, is like a single dot on the map, one destination. But a question is the entire map. It shows you all the possible places you could go. Each one of those sets of possible worlds is just one of those destinations, one of the potential answers. It's a really elegant way to give a concrete structure to the idea of uncertainty. So that's our first piece of the puzzle, questions as these maps of possibilities. Now let's pivot to the second part, the meaning behind proof and the power of inference. We're basically shifting gears from the act of asking to the science of proving. So here's a wild question. What actually gives a simple word like and its meaning? Well, according to proof-theoretic validity, it's not some abstract concept floating out in the ether. Nope. The meaning of and comes from one thing, how we use it. The rules of the game. We all know that if you have A and you have B, you're allowed to say A and B. And if you have A and B, you can pull out A. That's it. Those rules of inference, that is what and means. And this whole idea has a really interesting backstory. It all revolves around this famous proposal known as Prawitz's conjecture. Okay, so here's the story. Prawitz suggested that this whole proof-based system could be a new way to understand something called intuitionistic logic, which is just a very strict form of logic. Now, for the twist, his original idea was eventually proven wrong. But, and this is the really cool part, the idea didn't just vanish. Instead of being a foundation, it turned out to be the perfect tool for explaining something called harmony, which is basically just the idea that the rules for words like and or have to be balanced and consistent. So a failed conjecture actually became this incredibly useful tool. Science is awesome like that, right? Okay, so wait a minute. A practical problem probably just popped into your head. If the validity of something depends on all the rules and all the ways you can use them, doesn't that mean you'd have to check, like, an infinite number of scenarios to be sure? I mean, that sounds completely impossible. And luckily, the answer is no, which is a huge relief. For the kind of logic most people use called propositional logic, the stuff that deals with basic true-false statements, it's been proven that this whole thing is decidable. That's just a fancy way of saying there's a definite, finite process you can follow to check if a rule is valid. So this isn't just some abstract philosophical idea, it's a real, workable tool for logicians. Okay, we've got our two big ideas on the table. On one side, we have the logic of questions. On the other, the logic of proofs. So, Section 3 is all about the surprising connection, about building the bridge between them. This is where it all comes together. And this is really the central mystery, isn't it? What could possibly connect these two worlds? I mean, think about it. The logic of questions is all about opening things up, creating possibilities. The logic of proofs is about shutting things down, finding that one single solid conclusion. They seem like total opposites. So how could they possibly be related? Well, it turns out the connection isn't just some little overlap. It is a deep, fundamental alignment. The big discovery is something called extensional alignment. Now, let me try to explain that with an analogy. Imagine you have two things. One is a giant rulebook listing every single valid move you can make in a game of chess. The other is the blueprint for the chessboard itself, defining the space where the game happens. What researchers found is that the rulebook of proofs and the blueprint of questions were the same thing. They looked completely different, but they were describing the exact same underlying structure. And this was huge. I mean, it officially connected these two fields and solved a major question that had been bugging logicians for a long time. Now, this connection is amazing for sure, but it's really important to understand that this is just one piece of a much larger puzzle. So for our last section, let's look at other ways to ask, because this is definitely not the only path. Yeah, this discovery is happening inside a really active field. You've got lots of other researchers coming at this from different angles. They're building things like erotetic calculus or these interrogative models of inquiry. And really, what all of this work points to is one massive takeaway. The question is finally being seen as just as fundamental, just as important to logic as the answer has always been. So, if there's one thing to take away from all this, it's this right here. A question is so much more than just a bunch of words with a question mark tacked on to the end. In modern logic, a question is treated as a fundamental object, every bit as real and important as a number or a true-false statement. It has its own deep, complex structure that, honestly, we're just now starting to really get our heads around. And that kind of brings us full circle, leaving us with one last big question to ponder. We've seen that logic can give us the tools to understand the very nature of a question. So, if we now have the power to formalize the act of asking, what's the next big question we should be asking?